Hi, everyone. My name is Puneet Bogra. I am the IoT segment leader for APJ. Welcome to the AWS IoT Digital Roadshow for APJ. We're going to be talking about today how modern manufacturing approaches to improve product quality. And I'm also pleased to announce that we've got our partners joining the hands in this session. Chi Hao Lim, who's the CEO of Tapway, and Christopher Chin, Principal Analytics Engineer from Seek. Yesterday, you heard about how our partners are helping our customers driving productivity improvements in your industrial operation. Today, as I said earlier, we will be talking about how modern manufacturing approaches to improve product quality. And then tomorrow, you will also hear from other set of partners and my colleague about reducing downtime of your industrial assets using IoT and machine learning. So without further any delay, let's jump in. So today I'm going to start with sharing some of the manufacturing industry trends. And I purposefully kept data as an enabler in between because most of our customers are looking at data to be the key decision maker point. Leveraging this as a key point, they are trying to find ways and means to optimize their operation expenses or enhance their customer experience. To give you an example, Volkswagen is working with us to build some platforms on their manufacturing plants with the goal of enhancing productivity by a factor of 30%. Similarly, many customers are working on utility and reducing the cost for utilities that they spend on because it's one of the biggest ticket items. And by reducing the cost, they're also helping the sustainability factor that's looked upon right now. On the right side, we also have customers looking at how they can give better experience through connected products to their customers, whether it is better services or it could be giving them intelligent outcomes that they're looking at from the products. And then at the extreme end, we've got product as a service. Some of the machine manufacturers are also talking to us. How can they offer their machine not at a CapEx, but on an OpEx base? What it means is they're talking about how much productivity they can yield out of these machines is a cost factor for them rather than paying a huge amount of CapEx at the beginning of the purchase agreement. Now, quickly moving on to some of the key factors that impacts the operation cost for any smart factory, connected factory, whatever you consider that. But these are the key factors that we always keep on hearing back from our customers, our partners. And you heard about productivity yesterday with our colleagues. Today, we're going to talk about quality. And then tomorrow, you will also hear about availability from my other colleagues and some of the partners that we work very closely with. If you really look at productivity, quality, availability, combination of these three factors delivers overall equipment effectiveness, which is one of the leading parameters that every manufacturing industry customer today is looking upon to find how do they optimize their expenses and how do they increase their profits and margins. There are other use cases as well that comes to us, like asset tracking, supply chain control, demand forecasting. But we'll leave that for some other day, and we'll surely bring more insight as we move forward. With that, I would like to invite Chi Hao, the CEO of Tapway, to share some insights about how some of the innovative solutions that they have launched and they are helping our customers with. Chi Hao, all yours.
Thank you, Puneet, for the kind introduction. Hi, my name is Chi Hao. I'm from Tapway, and today I'll be sharing with you a little bit about how we automate quality inspection with AI vision. So first, just a little introduction of the company. So Tapway, we are a company based in Malaysia, and we started in 2014 with the goal to really leverage what we call video artificial intelligence technologies, and also with the use of certain connected sensors out there to help capture data in physical locations. So Tapway is all about making physical locations smarter, and how. Basically, there are three aspects. Number one, how we can use data in physical locations to streamline and automate operations. And number two, how we can use that to improve experiences. And number three, how we can also use data to enhance security and safety. So over the 7-8 years, we have deployed more than 2,000 sensors and cameras across all industries, including about 500 over locations and also in 3 different countries. So just a little bit more about our competencies. Of course, front and center is basically video AI, right? So video AI is all we do and our focus. But apart from that, we also have the element of IoT, which is really required when it comes to having edge computing devices connecting to to other machines and other cameras, as well as cloud, which is why we're here today. We have been an AWS user and a partner since day one when we started in 2014. So let's deep dive a little bit, and I think Punit has alluded to some of this before just now. But yeah, just to sort of capture the major manufacturing challenges right now, especially during this pandemic time. There are a couple of big ones. Of course, responding to COVID-19 it's a very big one because in this pandemic we should be reducing number of people working on the floor without impacting on your production volume, your productivity, right? So how do you actually get there? That is really the challenge today. Number two is how do you reduce reliance on manual low-skilled labor? So in order to reduce your overall workforce while maintaining your productivity, it's really how you are able to automate more of your low-skilled labor that are doing repetitive work. And of course, there are a lot of inefficiencies in the production workflow that you can really focus on. And another big thing is the inability right now to monitor machinery and equipment performance in real time. And that has also an impact on the quality aspect as well, apart from the overall operation of the factory. And finally, and most importantly, is how a lot of all this human inspection that's currently done still having very high errors. You're talking about fatigue, overwork, and just pure human errors contributing to a higher defect rate. So this, I hope, will give you an overview of the manufacturing challenges that are currently happening. So today I'll just tell you a little bit about what we do in Tapway and what sort of solutions we provide for the manufacturing sector. So today, we'll talk a little bit more about the bottom side here, which is automated inspection system. So this is really catering for quality inspection and how we can automate it with the help of robotics and our vision system. And of course, we also do other things. One of the big one is to be able to connect to machine data collection. This could be a topic that is covered in another day. But yeah, I'll also give you a brief overview about how we do that, especially with the really good platform developed by AWS called the AWS IoT Sitewise. And we also do a lot of location tracking solutions by providing what we call Bluetooth tags as well to help track movement of people inside the factory. And this is especially helpful for the COVID times for contact tracing purposes. And finally, inventory tracking. And that's also a big one to cover, which definitely we'll get to one day. So a little bit about Vision Track. So this is basically the end-to-end visual inspection platform that is really designed to accelerate what we call customized object detection and image classification model. So it could be a handful. What it really means is that for every factory and every product, you will have your own unique defects, right? That you can't actually buy something off the shelf and just run it and you start detecting this defect. It is impossible to get there. So what we do is to create a platform that we can iterate and really train a model very fast, right? And today I'll also share a little bit about a platform that AWS developed to help us to get at least some early results. And paired with robotics, really, you can really help eliminate manual low-skilled labor, because now you can then replace human eyes for inspection and then replace human arms with robotic arms or certain pneumatic devices that can simulate removing a product that is not good. So how it works really, the training process is pretty simple. So for those of you who are familiar with AI or what we call deep learning or neural network, it's really like a baby, right? So it's like baby learning through images or examples. For example, if you feed a baby with 4 different images of different shape and form of bottle, the baby will start forming certain characteristics of how a bottle should be, right? So if you maybe pass on or feed another image of a metallic bottle, he or she may be confused at first. But if you feed more example of that and say this is also a bottle, then he or she would learn that this is also falling into the category of bottle. So it's the same how we do that. It's really that for every single product defect, so a defect type, for example, a crack, let's use crack as an example. If you feed that maybe 10 times of 10 different variations of this defect to our system, we will then label this, right? So we will then, we have our workforce to label each of these images as the training data for our AI model. Then what we do is by leveraging SageMaker, which is a really awesome platform developed by AWS, we are able to really quickly build, train, and tune the AI model. So it's an iterative process, but this is all happening under the hood, right? And what we do is we'll find the model that has the highest accuracy, that is best suited for this specific use case. And once we have done that, we have automated deployment pipeline to deploy this to an edge computing device, or we call that an edge AI server. So yeah, once it's ready, then we'll go to the next slide, which is how it works in real-time operation, right? So on the right-hand side here, you'll see that there are various cameras. So the placement of the camera is very important so that you don't miss any side of the product. So you don't have any blind spot, make sure that is covered. And once that is done, these cameras will be streamed to our AI server. And we will have basically the inference model doing the inference and to detect whether it is okay or it is NG. In the quality world, we call it NG, or not good, right? So yeah, once, let's say there is defect detected, we can then send a signal or send a command over to a controller and basically instruct the robotic arm to remove that particular product. So that's essentially how it works to really automate the entire quality inspection process. So maybe comparison, why are we doing deep learning or AI vision, right? What's the advantage here? So number one, if you compare to human inspector, you will definitely be able to achieve faster inspection speed due to the superhuman nature of camera being able to do 30 frames per second. So you can really analyze 30 frames per second instead of maybe human with a little slower speed of inspecting. So that already gives you the advantage there. But most importantly is the second point, right? As I have alluded to, human errors and fatigue, right? And just being distracted sometimes. So you have more consistency and definitely more reliability because machine will never be tired. Machine will never be distracted. Yeah, and compared to traditional machine vision, so traditional machine vision is something that has been existing for decades, and it's really based on manipulating pixels on an image, right? And it is pretty good for certain things like measurement, gauging, things like that, or just pure simple RGB like color detection, things like that. But it is not really suitable for very complex use cases. And that's why using deep learning can help to train model that can detect various kinds of cracks. You can have cracks that is just a hairline. It can be basically, an X shape or just multiple tree branches shape. That's an area that AI is particularly suited for. And most of all, there's no calibration required. It's all just about training, right? So it's a lot easier and faster to set up. So I'll just touch a little bit on this because I've alluded to already in the previous slide. Really, it helps to tackle complex cosmetic inspection use cases. It helps to do texture and material classification. And this area is basically where classification is on the spectrum, right? For example, maybe you're talking about detecting metallic surfaces that are glossy versus matte. It could be sometimes in the middle. It's neither glossy or matte, or it's really, upon the eye of the beholder, the human inspector. So in this case, it is good to standardize this using AI to know where the line is between A and B, for example. And then, of course, OCR is something that traditional machine vision can do, but there are a lot of cases like the bottle that I showed you just now, where there is a curvature on the text, and sometimes that is something that traditional model can struggle with. Hence, you need AI to do that problem, or to solve that problem, basically. I'll move on to deliverables, because it's very, very important to every manufacturer out there. Why should we invest? Why should we do this? And what's gonna be the benefits to them, right? Of course, these are the numbers that we have gathered across the industry, but it really depends on your unique case and your circumstances, right? But at least what you will have is improved quality inspection output because of the speed that we can produce with machine. And number two is definitely reduction in defects. Having less human errors and more consistency, you'll definitely be able to achieve that. And finally, being able to automate would mean that reduction in QC workforce. So this will help you to sort of move some of your low-skilled labor to higher skilled, train them to do more higher skilled tasks, basically. And that's really to advance the economy to Industry 4.0. So I'll just touch briefly about Connected Factory, because it's not just about recognizing or analyzing the product, whether it's defective or not, but also to capture this data and send it to the cloud. So we have this Connected Factory platform, which I'll just touch very briefly. It's a platform that uses IoT Sitewise, which is a platform provided by AWS to send data easily to the cloud through an edge computing device. We call that an IoT gateway. So yeah, so how it works is pretty simple. Again, leveraging the same edge computing device that is used for inference, AI inference. Now you can basically use that to connect to different machines. For example, if there is a robotic arm, if there is basically a machine, you can connect to that and to get certain data out of that, right? And we work with partners out there that already have integrated with various different machines to really help accelerate this process. And once the data is in the cloud, you can easily create dashboard and provide this dashboard for really access from anywhere, right? So that's the power of cloud. And the methodology is really purely very simple. It's really just in the case of quality, to connect to machines to get measurements, especially when it comes to defect, to be able to collect real-time information about that. If in any case the machine is probably 30 years old, it's analog, you can't really capture the data, you can introduce secondary sensors as well. Once you have that, it's really then to design your quality KPI and run the 6 big losses analysis. There are 2 of them related to quality, right? So you can also run that analysis to really find out how you can reduce quality losses, and to build predictive models based on the data to really optimize that process. And finally, yeah, once you're able to fix the root causes, the next step is how do you automate it? So that's where automation comes in on the machine side of things, not so much on the vision track that I have already spoken about in terms of automation. So yeah, the feature of the Connected Factory is really simple. It's being able for you to access OEE, which Punit has alluded to just now, from anywhere really, and really to help you reduce losses, reduce defects, and boost production output once you're able to identify the 6 big losses and minimize those. And of course, yeah, I think predictive is a very big element in this because the next slide, I think I will explain more about that, right? So how do you really how can you achieve predictive maintenance really to help to go along this route of level 1 to 4. So level 1 is really to fix when things are broken. So that's how it is in a lot of different manufacturers right now in the world. Unfortunately, we are still there. There are a lot of people now in level 2 where it's just based on what the machinery supplier says in terms of a maintenance schedule. So you just follow that. Maybe you say, hey, this requires maybe a certain downtime every month, and you just follow that, right? But number 3 is something that can be done easily when you implement site-wise, and that is that by referring to data, maybe the schedule can be changed. It shouldn't be done every month. It should be done every week, because this machine goes down much faster, and there are certain things that you need to monitor and maintain, right? And number 4 is to be able to use data to predict before the machine goes down. Yeah, so that's basically the 4 levels of predictive maintenance. And again, by using the connected factory platform, you will be able to have reduced downtime, reduction in defects, improvement in cycle time, which is out of probably the quality discussion today. But yeah, the main thing here is really when you reduce defects, it will help you to also boost your OEE as well. So yeah, maybe before that, before the demo, I'll just give you a case study. And this is really also something that you can see from the AWS website. So this company, Data Profit, they have been able to cut manufacturing defect to 0. And really the challenge for them is the high defect output in the pipeline, causing a lot of wastage of material and also increased production costs as well. So by using what I've just mentioned just now, using AI vision, trained model to accurately identify defect and be able to remove this defected item and to be able to improve their production process, they were able to reduce defect all the way to 0. So basically, the results are stark, right? The cost of producing 40 parts is reduced right now by 40%, scrap rate 0, and the big ROI here is they're able to save more than 10 million USD per month. So that's just one example out there. Of course, it's a big company, and it could be, there could be a lot of other examples out there. That could be a smaller manufacturer, but yeah, basically by this is a good example to show that there is certain cost savings and definitely higher productivity, which means higher top line for some of these implementations, definitely. So with that, I'll move on to a quick demo just to show you a little bit about a platform that AWS has developed. So Lookup for Vision was released about a year ago. So this is a platform for you to quickly train a model and to be able to provide results very quickly through a GUI, and you really do not require any deep learning skills at all if you want to jump on this immediately. It is normally used internally by the company as a first cut to really measure how well or how complex the defect would be. And before we start our internal process, we have a much more complex automated platform that is separate from Lookup for Vision. But this is a really good platform as well. So I'll show you basically an example today. So this is a pen manufacturer, and basically we have gotten some examples, some images of various defects that they have. And basically what you can do is first thing to upload images. So we call it data set. So in this example, 151 images have been uploaded to the system. And you are able to then start the labeling process, which we have done. So we can basically label images that are okay and images that are NG, basically. Or we call it as anomaly over here. So once that is done, all you have to do is just to train the model. That's as simple as it gets. And basically, you can train it multiple times with different parameters or different settings or different images that you like to select. So this helps you to really iterate quickly on your experiments, right? So these are all what we call experiments that you can do and to find the highest accuracy. So once that is done, you get this really, really nice interface of, what is the precision? So what is the accuracy basically? Overall, we have separated 24 images out of these 151 images as we call it validation data set. So they are training data and they are validation data. 23 anomalies were correct out of 24, which is really awesome. And with more images, you can potentially boost this all the way to 99% and more, or as close or even better than your human inspection currently. So yeah, this will show you a bit more results. We call it this confusion matrix, like what is predicted as normal, what is the false negative and the false positive basically. And again, the results are shown for each of them, correct or incorrect. You can see that directly in the interface. And another thing you can do is just to do a trial detection, right? So you can run a trial detection, feed some images, new images that have not been, have not been added, and then basically just click verify machine prediction by you verifying whether it's correct or not. And that is another thing that can be done manually, that is not directly done during the training process. So I hope this gives you an overview of how a model can be trained, and it can be done in minutes really. So it's just so fast. Under the hood, we do a lot of other things. Of course, we started training different models, and we were able to, using our internal system, to find out certain very advanced things that I can show here. For example, loss rate. As for, like, you can see a lot of different models that we have trained, and the loss rate. Of course, what we want to do is to reduce losses in the deep learning world to the minimum, right? So this is just something advanced that we do under the hood, just to let you know about something that we do. And in terms of dashboard, I would just like to give you a quick example of the dashboard. So this is actually done on Kibana, which is basically a managed Elasticsearch service that you can find in AWS as well. It's really plain and simple. That once data comes into Elasticsearch through Kinesis or another platform, you can basically just populate the results very quickly, build your own dashboard as well. So in this example, we have like the total product count by the last 24 hours. You can just quickly select maybe last 7 days, for example, and you'll be able to see the results for the last 7 days. And we will give you certain report like this. This maybe show you we have 4, 5, 6 different classes of defects, and what is the accuracy rate for each of them. So if you see certain problem like this, maybe for class 6 we will need to train the model a bit more to increase the accuracy to maybe somewhere about 97%, like the rest of the classes. And you can see basically the overall accuracy. So this is basically defect rate that, or the errors that the model is still having. And you can see that day by day, whether it's increasing or decreasing, whether you want to analyze daytime performance, nighttime performance. If you have sort of a semi-outdoor factory with certain lighting variation, that could be affecting the accuracy sometimes. Of course, there's a lot more analysis that you can see, the by classes and other charts, by hourly, even by factory ID. If you have, let's say, a lot of factories, you can zoom in by factory and zoom in by even line ID, like your production line ID. So yeah, this gives you just a quick overview. Of course, there are a lot of other charts that we built. For example, if it's a defect, what is actually the defect, right? And then to zoom into certain things on the defect as well, what could be the issue. So this really helps to give a window of how the model is performing and what should be trained and retrained to improve the accuracy further to your target or your desired deliverable. So I hope you enjoyed this demo. And with that, I'll wrap it up and pass it back to Christopher.
So hello everyone, my name is Christopher Chin. I'm the Principal Analytics Engineer leading a team based in Kuala Lumpur supporting SIG customers in Asia Pacific region. So today I'll share with you on how SIG helps with customers to apply advanced analytics in process manufacturing. And before I begin I'll jump into the demo. So primarily I'll be showing more of a demo of how we apply that application. So you can see SIG enables organizations to improve production outcomes, yield, quality, and asset availability through advanced analytics. So you can see the application at the center, which is what we call as SIG Workbench. So SIG Workbench is a browser-based application for the investigation of time series data. So SIG Workbench provides data visualization and advanced analytics tools such as visual search and capsule capabilities. So that I'll show during the demo for more explanation. And the application on the left, which is what we call as a SIG Organizer, is a browser-based application to assemble SIG analysis and visualizations into reports, presentations, and meeting agendas. So SIG Organizer documents are dynamic because they are tied directly to the underlying data and are time relative, so that they can be defined by any batch, shift, day, or user-defined time period. Okay, and the application on the far right is what we call as a SIG Data Lab. It's a service that brings together Jupyter Notebooks, which is a web application that combines Python Markdown with SIG API. So this enables users to create Python-based notebooks and use a custom SIG Python library that we distribute to push, pull, and manipulate data using SIG, and then develop reports and visualizations using that data. So we take a look at in the center, SIG Cortex. So primarily it's a server, right? It's what we call as a SIG server. It's an application that server for SIG Workbench and Organizer, as well as a SIG Data Lab. So it can be run on a desktop system, a server, or in the cloud interface, such as we can have it data that is parked in AWS, as well as we can combine data sources, right? Remote data connections from on-prem as well. So historians, as I mentioned. So related to historian, so connecting data historians, sources, and silos. So no matter where your data is stored, on-prem or in the cloud, it could be in historian or AWS data service. So SIG can connect to it without any duplication. And data is not moved or copied, so that the system of record integrity is not impacted by using SIG with this when you're using SIG with these data sources. So in terms of deployment, SIG may be set up and run on a dedicated server or a virtual machine in less than an hour. So depending on the tag counts, and for on-premise installation are typically on the same network or as a plant enterprise historian. However, SIG may also be deployed in cloud as a hosted application or a SaaS on AWS. So today I'll be going through a demo, okay, to show how SIG provides rapid insights for example use case here, which is focused on batch analytics and monitoring. So one of the largest challenges in batch process monitoring or report generation is to gather data from many different sources, right? It could be from process lab, maintenance, or Spectra sources into a single environment. So the SIG server takes this burden off the user by indexing data from all varieties of data sources and making it available to users in a single interface in the SIG Workbench. So they can quickly then calculate statistical limits, KPIs, and aggregations using robust analytics tools. And any calculated items can be easily audited to track the changes, ensuring compliance with the current good manufacturing practice, CGMP calculations. So these trends and metrics can then be assembled into a static reports or live updating dashboard in the organizer topic. So this dashboard can also include custom visualizations generated in SIG Data Lab, as well as free-form text input notes provided by the subject matter expert on the process operation. So yeah, without further delay, I will just let's jump into the demo to show this use case in action. Okay, so what you're seeing on screen now is how SIG Workbench looks like. So on the left corner, you can see currently there are 11 different data sources that is connected to SIG Workbench. So we have some CSV files. Yeah, we have about 1,500 tags that's indexed. And then if I scroll all the way down here, we have some Amazon Redshift connected data source with 20 items indexed, right? And then we have initial gateway, Pi, AF, and Pi tags, right? As I mentioned, no data is being copied, but then this is what we call as index when the metadata is being read on over to the SIG Workbench. So here you can see that currently we will be talking about a penicillin manufacturer, okay, which is from a biopharmaceutical industry. So basically, what I'm going to show in this demo is that how the cell culture process in upstream can be. We will create a model for this product, okay, and then we will use this model, okay, to deploy in the model for future batches with golden profiles for the what we call as CPP, which is the critical process parameters. So this is the journal part where the analysis has been completed and is part of the collaborative tool in SIG, where we can use to be shared among subject matter expert, as well as depending it could be management level as well, to walk through the analysis as we go through, right? So you can see the hyperlinks in each of these steps, which we call it as SIG links, okay, which documents each of these analysis. So let me go through the first step here, okay? So there are a total of 4 steps, and within these 4 steps, there are a lot of analytics that's being applied on the raw signals as we go on. So here, if I click on step 1, okay, so here we will connect and find the relevant signals for historical batches. So this includes information like the offline penicillin concentration samples from the LIMS database, process text from the data historian, and SAD batches from event frames or from the ERP system. So you can see these are data from various data sources that is being displayed here in the SIG Workbench itself. So you can see if I scroll all the way down, this is what you can see the bars at the top. This is what we call as conditions. So basically, if I click on penicillin batch with batch ID, is highlighted in dark blue, right? So this is the overall process for this particular batch of penicillin that is being produced. And I can break down this main batch into a smaller batches to understand the initial growth phase, which is highlighted here. And then we can have an insight about the rapid growth phase, productive growth operation, and constant production phase. So basically, we can break down of the main batch, right, production batch into respective conditions, right, to understand how much time is being spent for each of this phase. Okay, and then we can put the different batches of penicillin product side by side to understand what are the how are the critical process parameters are behaving. So we can include the information that I mentioned earlier, such as acid flow rate, base flow rate, dissolved oxygen concentration, and the rest that is being displayed here, which is used to build this model, right? So from this condition, you can see on the far right here, this is the capsule, which gives you the condition, the information such as batch ID and which of the operation phase that is currently in that phase, right? And we have the start and end time to understand the duration that is spent for each of this phase. So we move on to step 2 to you use the data, right, displayed here in step 1 to build a predictive model for the penicillin concentration as a function of other signal. So we have 2 options here. So the first one, I'll just click on step for number 2, which is inputs, right? We'll use the raw online signals as inputs to the model. So this model does not account for trajectory of the batch. So if I just click, will be the penicillin concentration signal, right? And this is the prediction that is built using the raw signal. So if I click on the edit button, so you can see that it's a point-and-click application where the subject matter expert does not need to have any coding experience. So all I need to do is the point-and-click, okay, to choose the signal to model here, which is the penicillin concentration signal, and then the input signals are the parameters that we've seen in step 1. So we can just input it here, right? As we click and insert here as the input signals. We define the training window. Okay, then currently we are using linear scale, and as we go down, right, we can at the bottom we can look at the prediction model to see how the parameters and the coefficients that is correlated for this model that we are trying to predict, and we can get information such as the R-square value for this prediction model is about 86%. Okay, just to give you an overview how this prediction tool looks like in Zeek. Okay, let's go back to the journal. And for option 2, we can calculate new statistical signal derived from online raw signal using knowledge of a process that is provided by the subject matter expert. So this is another, just to show how there are different ways of how we can build a prediction model based on the preference by the subject matter expert. Okay, then finally we can display the calculated signals here. Okay, after we have decided on whichever options that we prefer, so we can display the calculated signals for this step. Okay, and as an alternative option, let's say if you want like Zeek enables a collaboration, right, or collaborative effort with a data scientist team. So with users, there is more profound, okay, with Python skill, then they can use Data Lab as option 3 to build a more complex model such as PLS DA or OPLS DA. So that can be done on the Zeek Data Lab application, and you can push the results back into the workbench. Okay, so on step 3, we'll build a golden profile for the penicillin concentration for online monitoring. So let me click on this work step. And first, you can see the dark blue conditions, right, represents the various penicillin manufactured batches, right? And we would, in this step, we will identify the best batches, which is highlighted by this green bar at the top. So these green batches will be used as the baseline to build this golden profile. So next, right, we will go ahead and create the golden profile by applying statistical technique, right, by using limits of plus and negative 3 standard deviation. And yeah, once this is input here, you can see we have the upper and lower limit, right, defined, right, with the red signal. And then we have that target penicillin concentration highlighted by the purple signal. Okay, and the golden profile looks something like this. And finally, we'll deploy the model and the golden profiles on new batch in production. So let me click on this step here. So basically, the golden profile, right, that we built will be applied on each new future production, right, of the penicillin batches, and we will try to see whether it deviates away from the standard deviation that we have created in the golden profile, right? And lastly, after we have applied the golden profile on the new batches in production, then we can identify the causes of deviation, right, by clicking on this tab. and we can see the red condition, right? It highlights the penicillin deviation, right? So this is the part where it is, if I zoom in further, okay, if I click on the dimming function, and I can just click on, right, the condition here, and we can see that that's where it's the condition where it's deviating away from the golden profile. Okay, once we have completed this analysis here, right, this will be the part where the subject matter expert will complete the analysis in Workbench. And next, I will show how we can actually bring this analysis and publish it as an example of a batch report form. So this analysis, we can, if I scroll all the way down here, we can see that the golden profile analysis is part of the LIMS result, where we can add in information the analysis here, as well as we can have as a what we call as a scorecard metric in this table form to highlight any anomaly when it's above the deviation limits, right? So for each of this batch ID, batch ID, right, represents the penicillin production, right? We can actually break down into the different batches, and we can tabulate or summarize the information from the analysis that is completed in the Workbench, and use this as a what we call as a monitoring dashboard, or it could be a batch production report, which is being shown here. So we can add further context into the results that's been done in Workbench. So we can drill down into raw materials that has been used, the recipe of the to produce the penicillin, deviations when it's captured, the date and time, and what was the duration for each of these duration. And in terms of the critical process parameters, right, the results from that analysis can be shown in terms of time series trend, as well as traffic light system, right, indicator, where yellow means something that needs to be looked into, red will be something that needs to be looked into directly, right, immediately. And for further information, when this report is being shared with a management team, for example, or with a site team, they can just click on that table, okay, and then if you click on the edit worksheet, you will bring directly the user to the analysis in the Workbench on where the highlighted anomaly was created or was found. Okay. And as I mentioned in the beginning, so the dashboard, once it is created, right, you can actually assign a date range where these trends can be updated on a periodic period. So for example here, this is currently assigned with a fixed date range with using that is based on the penicillin batches where production schedule. All right. With that, I end my demo here. And if there's any questions that is, you're interested to know more about the demo or anything that is related to this presentation, do let me know. Thank you.